Now let's talk about what is null and alternate hypothesis. First of all, let's talk about what is hypothesis testing. So as you could see on the screen, which is a simple example that I'm trying to highlight here, everybody knows, or every baby knows, the scientific method, which is hypothesis testing. So if you understand about the steps that are highlighted here, which represents a simple action that a baby is trying to pick an object and trying to taste it and trying to identify some findings, and then based on his findings or the baby findings, it's trying to do further actions. So what is hypothesis test? Any action in this entire universe, can be considered as hypothesis testing, or can be considered to be as conducting hypothesis testing. A baby is trying to make an observation by looking at an object as a step 1. Step 2, he is forming a hypothesis saying, I wanted to test this object, which means he formed a hypothesis test saying, I wanted to test this object. And then he will conduct his experiment by testing that object, and he will do his analysis. When he feels the test is good, then he will find his analysis saying that he will report his findings. Or if the object of the test tastes good, then he will try to further offer that object to maybe another kids, and that's what your final outcome is expected to be. And this is a very simple step or simple example that we can talk about our hypothesis test. Let's get into some general or real-time problem that we are going to talk about the hypothesis test. As scientists, or either data scientists, or either any scientist across the globe, or always tries to prove that entire world is wrong, or either we always try to prove something which is new, we will call anything as null hypothesis, which means whatever the test that we wanted to prove, by default we will consider that the formula that we are going to create or the formula that we are going to work on is going to fail, which we call it as null hypothesis. Which means as a step 1, you should form your hypothesis. Immediately you will be forming your null hypothesis, which means your research is going to fail. For an example, you could see, if I'm a scientist who is trying to create a biofertilizer, and I'll be expecting the growth of this plant is going to be better than the other plants. So I'll be by default forming my hypothesis, which says that okay, the growth of this plant will be good if you use this biofertilizer. But that's not the way I will proceed for my hypothesis test. As a first step, I will be forming hypothesis test and null hypothesis, which means I will consider that the formula or the fertilizer that I'm going to create is going to fail. So I will start taking this null hypothesis and I will try to prove that this null hypothesis can be accepted or can be rejected. So that is the universal standard way of people will be forming the null hypothesis. So after I start conducting my test, maybe for so and so number of days, consider that this fertilizer results can be analyzed maybe after 100 days. I will do the test and I will compare the results with the normal other plant or either the plant which is fed with this biofertilizer, and based on the results I will take my decision whether to accept the null hypothesis, whether to reject the null hypothesis. As you could see, the flow of a hypothesis testing here, and first I will be developing the research hypothesis and null hypothesis, which means whatever that I wanted to prove will be by default considering the null hypothesis as true, which means the fertilizer that I am going to create is not going to work, or the fertilizer that I have or the formula that I have created is going to fail. That's what we call it as null hypothesis. And we will set the alpha value. What is this alpha value? So if you start conducting your test using a single plant, due to any natural issues or any other problems, your plant might die because of some other reasons which can not be stopped, which you don't know, that whether the test is going to be really successful or not. So in real time, what any scientist will do, we will take n number of observations, which means n number of plants to test a particular fertilizer. Maybe let's assume that we are going to consider 100 plants for testing purpose. So maybe another 100 plants for negative cases, like by using some other chemical fertilizers, and we'll be using the biofertilizer, maybe some organic fertilizer on the other side, which we are trying to prove. So I will conduct the test and I will come to a conclusion based on number of observations which are giving proper results. Let's say for an example, if I take 100 plants to test that the growth of the plant will be good based on the biofertilizer that I am going to feed, I will choose my alpha value as a threshold value, which means I will choose a threshold value of 5 out of 100. If any of the 5 plants which doesn't show good results out of my 100 plants that I am trying to test, I will say that yes, I am okay to proceed further to consider my biofertilizer as a good product. If any of the plants fails to prove my results, or either greater than 5 plants out of my 100 plants, if any of the greater than 5 plants are died or showing some wrong results, I will consider to choose that my formula that I have created is failed, and I will proceed further to do further research, and I will come up with a different formula to improve my biofertilizer. So here I will be setting my alpha value as 5, which is a universal number, and based on the type of test that you are conducting, based on the risk which is involved in your testing, you can also change your own alpha value, but universally people will consider to have your alpha value as 0.05, which is nothing but 5% of your observations. So and then you will, the step which is showing us calculate the power to determine the sample size, which means that yes, you identify, you do your hypothesis test, whatever the test that you want to conduct, like feed your objects with your biofertilizer, and then get the values of it, and then do all the testing, collect all the dependent variable and everything. Once you got your data, and then you will be able to identify how many plants are showing good results and how many plants are showing bad results, which means greater than normal or less than normal. If it is greater than normal growth, yes, you are good, and if it is greater than greater than normal, which is a bad side. So you will compare your alpha value with your p value, which is nothing but what is the actual number of plants which are showing good results or either bad results. So you compare your value with alpha, the p value with your alpha. If the p value is less than 0.05, which means the number of plants which are showing bad results is less than 5, you are going to consider, you are going to call as, I am going to reject my null hypothesis, which means the formula that you have created is good to go to the market. The formula that you have created is successful, and then you are good to go to the market. Your fertilizer is good to go for the market. And if the p value is greater than the threshold value that you have chosen, which means the number of failed observations are greater than 5 out of 100, then you will fail to reject the null hypothesis, which means you will still have to continue to do your research and then do or come up with a new formula that is going to work on top of your plans properly. So when someone says that reject null hypothesis, we are good to go, and the test that you have conducted is successful, because we always consider the null hypothesis is correct, and you will always try to reject the null hypothesis to prove that your testing or the formula that you have created is going to be successful. So that's how your hypothesis testing can be conducted for any test that you want to conduct for any hypothesis world. So this is how the process flow will happen in any statistical world, and that's what we call it as hypothesis testing. And if you look at, for example, you can also keep your number of observations into an accept region, accept null region, or reject null region. So rather than representing or presenting your data with respect to numbers, you can also form a distribution chart for that, where you can see, considering that there can be positive cases, there can be negative cases. Let's say for an example, there can be some plants which can go less or grow less than the minimum value, or there can be some plants which can grow beyond your expected value, which are overgrown. So You can also consider your negative cases or also positive cases, which means when I say positive means the overgrown cases can also be considered as negative, for an example. So in that case, if you keep your frequency of your past or either failed test cases, this is how you can have your distribution. And this region is nothing but accept null hypothesis, and if any of your count is lying in any of your green region, which means reject null hypothesis, which means that your test is conducted successfully and then you are good to go. So if you convert your test results into this distribution, and this is how you can form your frequency distribution, which can talk about accept null or the reject null distribution.